I know, right? We left off here, and we were discussing the ways to deal with that as opposed to the vertex form, right? And we already knew these two things, and then we discovered through experimentation that we had two choices. If it completes the square, we get vertex form, so it's easy to graph, right? But there are times when we don't want to complete the square. Well, you guys never want to complete the square because you don't like completing the square. Even though it's far and away the fastest and easiest thing to do, I will never convince you of that. Especially, okay, Sajot, I got you. Especially since you saw the quadratic formula. Because once you saw the quadratic formula, you don't want to factor, you don't want to complete the square, you just want to use the quadratic formula because it lets you use your calculators, and that's really the only thing you guys want to do in math class. You don't want to think. Thinking sucks.
Abby Panther, sorry for this interruption. We're doing things a bit out of order today. I'm going to read today's analysis.
So, sometimes, as I was saying, you don't want to complete the square, so you go through the quadratic formula. But, like we found in our very first experiment on this page, when we did the quadratic formula, it got us really ugly roots, right? It got us, like, you get a perfect die job, but then you forget about it, and then the roots come back. You know, it costs a lot to look that cheap. So, hear what I did there? Nobody? Okay, never mind. So, the roots might be ugly. Yeah? So, these two numbers right here could be really, really gross. And let's be honest, do the roots really help us graph? Not, especially not if they're barfy, right? So, don't write this down, just watch. Over here, I have a quadratic equation. How do you know it's quadratic? He waited patiently. Preston. Excellent, it has an x squared. Good, that's all you need to be quadratic. Okay. Does it factor? No, of course not. There are no factors of 11 that add to 6, so it does not factor. So, we could complete the square, but of course, we all don't like completing the square, especially if that is odd, right? Or if there's a number there. We don't like to complete the square, right? So I'm going to do this with a really easy one just to show you the thing I'm about to show you. Everybody cool? So since we can't complete the square, and we really can't, no air quotes, we really can't factor this, what's our only other option? Quadratic formula, yes? Now, if we run this through the quadratic formula, we get negative 6 plus or minus the root of 36 minus 44, yeah? Right? Which doesn't work, yeah? Oh, sorry, plus 44, which is 80, yeah? 6 plus or minus root 80 over 2, yeah? Root 80 is 16 times 5, so it's negative 6 plus or minus 4 root 5 over 2, which is negative 3 plus or minus 2 root 5. Agreed? Does that help us graph it? Not really, because now we know negative 3, the root of 5 is about 2. 2 times 2 is 4. Negative 3 plus 4 is 1. Negative 3 minus 4 is negative 7. Yeah? Ignore that dot. Right? Approximately. Does that help us graph it? No, not really, because we don't have a vertex. But we know something about the vertex, don't we? Where is the vertex? It's on the axis of symmetry, yes? What do we know about the axis of symmetry? It's exactly halfway between the two, yes? Now, between 1 and 7, it's real easy to find, but that is not real easy to work with, is it? So watch this. And I know you guys won't think it's cool, but I think it's cool, so I'm going to show it to you anyway, because I'm the boss of me. All right? So, we were going to run this through the quadratic equation, yes? I'm going to make a small change to the quadratic equation that isn't really a change at all. You know the quadratic equation as this. Correct? is it not the same to write it as such? Everyone's okay with that step? Yeah? Okay. Now I'm going to do something here that some of you will not like, but you'll see why when I finish what I'm talking about. This is hideous, yes? Like, that's a mess, right? That's the hard part of the quadratic equation. That's often where you got to break out your calculator. I just screwed it up recently because I did -8 or whatever it was, right? Okay. So I'm going to, because this part isn't important to what I'm doing, I'm going to get rid of it, and I'm just going to call it D. Everybody cool? Or A or Q. It doesn't matter. I don't want to use A, B, or C because we've already got A, B, and C in here, yeah? So I'm going to call it D. Is everyone okay with that? So now I have -B over 2A plus D, right? Or -B over 2A minus D, right? Those are my two options for roots, yeah? And those roots, not negative, not positive, but one of those roots is going to be on the left somewhere, and the other one's going to be on the right. Now, this one I did positive and negative, right? But they could be positive and positive. They could be negative and negative. It just doesn't matter. You just have to be aware. I'm not even going to put a Y on here. This is the x-axis. You know that root 1 and root 2 have to show up like that if there's two roots, right? Like if it just bounces, there's one root. But if there are two roots, you're aware that that's what it's going to look like on the x-axis, yes? Now, somebody say any two numbers. 7 and 3. Cool. So, which is on the left on the number line, 7 or 3? 3. Where's 7? Over here. What is the axis of symmetry? Pardon? 5. Why? Because it's in the middle too. How did you know 5 was in the middle? What did you do? You did the average, right? You added 7 plus 3 divided by 2 and got 5. Everyone agrees, yes? Everyone agrees, right? Okay. But watch this. This is root 1 and this is root 2 now. Everybody cool? So root 1 is on the left, root 2 is on the right. Agreed? So now, logically, since you added 3 and 7 and divided by 2, couldn't you add root 1 and root 2 and divide by 2? Everyone agrees? Now, when we did 3 plus 7, we got a number. We got 5. Was that an x or a y value? That was the x value, and it was the vertex x value, yes? Okay, so root 1, -b over 2a plus d, plus root 2, -b over 2a minus d, divided by 2, should give me the x value, yes? Just like it was with 3 and 7. Do we agree? Okay. What's -b over 2a plus -b over 2a? No. It's a negative plus a negative. -2b over 2a, right? Right? And what is d plus -d? Now McKenna. 0. Right? And then all of that is what? Divided by 2. Now, isn't divided by 2 -2b over 2a times 1/2? Okay, what's -2b times 1? This is not tricky. -2b. I hate how long it takes 30 of you to give me the answer of anything times 1. It's hurtful to me as your math teacher. What? Where am I multiplying, Jose? What's that say? Okay. Over. Now, guys, this one's a little trickier. What's 2a times 2? Oh, hey, you nailed that one. Good job. Now, what are you going to do with those? To what? Negative b over 2a, right? Now, when it was 3 plus 7 over 2, that got me 5, and 5 was the Vx, yes? Well, isn't this 3 plus 7 over 2? Root 1 plus root 2 over 2? So doesn't this equal the Vx? Equal the Vx? And then when we simplified this, didn't we get this? So doesn't that equal the Vx? So can I not find the vertex x value using just that? Everybody understand? New tool to do the job. And oh look, I've got it right here for you. Turn on to page 107. I think it is pretty cool, actually, that the numbers work out that way. Number theory is actually pretty neat. All right, so I want you to graph these. Now, I have given you a cheat code, essentially, right? Because the question says, I want it in this form. And like I told you, sometimes they use H and K instead of P and Q. That's why I'm using both, because it depends on who your teacher next year is, if they use a textbook, whatever, right? Some people use H and K. So, I want that form. Now, we know we can get that form by doing what? Just completing the square, right? But I know you guys hate completing the square. So, does this first one lend itself well to completing the square? It does, doesn't it? Why? What makes a nice one for completing the square? B is even, and there's no a, right? What's a? 1. So it's easy to work with, yeah? So let's complete the square on that one. You could all do it in your sleep. Y plus 6 equals, not bracket, x squared plus 10x plus 25. What do I got to add here? 25. Y plus 31 equals x plus 5 squared. Y equals x plus 5 squared minus 31. Right? Do that in their sleep. Everybody agrees, yeah? Okay, and then we sketch the graph. We know it's at negative 5, negative 31. We know the y-intercept is what? Negative 6, right? So I got a y-intercept right there at 0, negative 6. How far away is that from the axis of symmetry? 5. So how far do I got to go that way at negative 6? 5 out to what? Negative 10, negative 6. And then I graph. Easy peasy, right? Everyone's cool with that, yeah? And we check. I went over 5. I should go up 25. Is negative 31 to negative 6 25? So I did it right. Everybody good? Okay. Now let's look at B. If I was a mean teacher, because some teachers don't let you use that formula, they don't even tell you it exists. If I was a mean teacher, what would you have to do with B? You'd have to complete the square with what? Fractions. Blech. Get out your depends, because you're going to lose bladder control now, yes? But your teacher wants you to have every mathematical tool available to you, because your teacher is a giant mathematical tool. Okay? Get what I did there? Excellent. So, what is that math tool I gave you? I gave you this. The Vx equals negative b over 2a. Now, this is still going to be barfy, right? Because what is negative b over 2a? 5 over 2. I'm still stuck with a fraction, right? I'm still stuck with it. But it's still like I say, there's not necessarily a better or worse way to do it. It's just another way to do it. Now, here's where kids screw up. What is that? That's the Vx. What is missing? The V of y, right? I need the vertex y. How will I find that? Is that an x value? So where does it go? Where can I put that value? It's an x value. Where can I put it, Crystal? In K? Every x I see can now be 5 halves. So that gets me 25 fourths minus 25 halves plus 2. Right? Right? 25 fourths plus 25 halves plus 2 is the same as 25 fourths plus, sorry, not plus, idiot head, minus 50 fourths, right? Plus, how many fourths? 8. What's 25 minus 50 plus 8? Yeah? Yeah? Now, do we have our vertex? Yes or no? It's not over 5, idiot. It's over 8. I mean, it's over 4. That's going to sound bad on the review, on the video. What if it's like somebody's first time they watch it, they hear somebody say idiot, let me say idiot. All of you know that I'm speaking to myself. So now, do I know my vertex? Most of you hate fractions, so what should I change this to? That is 2.5. Or the way you like to write it, and I hate it, 2.5. What's this guy? It's, of course, negative 4.25. But you guys don't want to write that. You guys insist on negative 4.25. Now, can you write it? What is it? Y equals what? No. What's our A value? Do we know? We don't know. But we do know because it's 1. Well, you said no, and then you said it's 1. So it's 1. X, what's our vertex? Positive 2.5, so how do I write it in the form? Squared. And what's my y value? And then it's easy to graph, isn't it? Because when I graph it, I go to positive 2.5 down here to negative 4.25. Right? Do I know the y-intercept? What is it? 2. So right there is 0, 2, correct? How far did I go that way to get to it? 2.5. So how far am I going to go that way? This is 2.5. How far does that have to be? What's 2.5 plus 2.5? So that's 5. And what's my y value? 2. And then I can graph it. So what I was saying was you can cheat by using this to get your vertex, then you get this. Everybody understand? So let's look at C. Is C a good candidate for complete the square? I would say it's half and half, right? It's a good candidate because it's got a 6, but it's a bad candidate because it's got a 3. So it would be up to you guys, right? The 3 is easy to work with. But since I just showed you this new little trick, I'm going to stick with that. Okay? So my vertex X is negative B over 2A. What is it? which equals... So if my Vx is 1, what is my Vy? How do I find it? Where does that 1 go? Wherever there's an x. 3 times 1 squared minus 6 times 1 plus 7. What's my Vy? What is it? 3 minus 6 plus 7 is 4. Now, do I know my vertex? 1, 4. Now, can I take that and put it into my vertex form? Yeah, because that's H and that's K, or that's P and that's Q, yes? Depending on what I've written. But I don't care because I can work with both of them. Y equals, what's my A? 3. X, what? Minus 1 squared plus 4. And then I graph it. How do I graph it? 1, 4. And where am I going? What's my y-intercept? 7, 0, 7. That's 1, 4. How far did I go that way? 1. So how far do I need to be here? 1 to my axis of symmetry. How far do I need to go this way? So what is that point right there? 2, 7. Boom. Cool? Now, what if I feel good about completing the square? That's pretty easy too, right? Y minus 7 equals 3x squared minus 2, right? Right? Minus 2x plus 1, half squared. 3 times 1 is 3 plus 3. Y minus 4 equals 3x minus 1 squared. Bring the 4 over. Y equals 3x minus 1 squared plus 4. Whoop. Whoop. Who decides? You decide. Right? You now have 4 options to work with these things. So what's D going to be? Which way do you want to go with D? The negative b over 2a or complete the square? Or do I just do both because it takes me the same amount of time? Sure, let's do both. Then I cover both people's choices, yes? In dark green, I'll do Vx equals negative b over 2a. What is it? You got to help me out a little at least. Negative 8 over negative 4, which is 2. So Vy is what? Negative 2 times what? 2 squared plus 8 times 2 minus. So what's Vy? Five. So now I can just go ahead and put it in slope-intercept form, can't I? I mean, slope-intercept form. It's been a long week. These 5-day weeks are killing me, man. Fortunately, in the next 5 weeks, we only have 1. I know, right? It's a tough job. Tough job being a teenager. All those hours you got to spend at school, 5 hours a day and a day off every week for the next 5. Whew! I don't know how you guys handle it. Next week, you have a 5-day week. The week after that, Remembrance Day, 4-day week. The week after that, 3-day week because of... Oh, yeah, don't forget Friday half day. Thursday's collab, so short periods. You start early. And don't forget the next week, you have day off for parent-teacher. And then the day after that's Pro D. Yeah, of the next 15 days, you're going to school for like 10. Yeah, don't forget the Remembrance Day assembly. Yeah, I know. Stressful, right? Noses to the grindstone. I don't know how you guys make it through this breakneck schedule you have. He said, voice dripping with sarcasm. I have to be here for all of that time. I have to be here all day for parent-teacher interviews. I have 4 classes of 30 kids a class. I should see 150 parents. But it's North America, so a lot of parents are split up, right? So let's say 200 parents that I deal with. I'll see 11. And I have a very high percentage of people who come to visit. There are teachers here that get no one. Well, I think it's more likely I got to see who this idiot is that's talking to my kids. Because I'm pretty sure you clowns go home and say, do what you do here. You hear everything I say, but you only listen to the stuff that'll either A, get me in trouble, or B, make you, right? Yeah, a lot of the parents I don't think are sitting around watching YouTube. However, I do get the odd parent that's like, my kid watches your videos at the dinner table after dinner, and I got to listen to it all night. They don't sound like that, right? I mean, obviously, we're not in the deep south, but I have had parents say that. And sometimes they're like, yeah, you're a pretty funny guy. And sometimes they're like, if I hear your voice one more time, I'm going to take a fork, I'm going to stab it in my ear. No, they're not. Hi, parents. Matt Myers. Okay, so I've got my vertex, yes? Can I go right to vertex form? Yeah, because it's y equals what? Negative 2x minus 2 squared plus 5. Then I graph it in 2 seconds. 2, 5, negative 2. My y-intercept was 3, 0, 3. So that's 2 away. So this is 2, 5. So what's this one going to be? I don't know. Is it? You guys said 3. I had it off the screen. No. A was negative 2. So it's negative 3, 0. So what's this point out here? Still negative 3. I went 2 that way, so I went 2 that way. So what's this? 4. And then I check. I went over 2. I should have gone down 4, but there's an A value, so I had to go down 8. Is negative 3 8 down from 5? So did I graph it correctly? Of course I did. Then I will change shades of green. Y equals negative 2x squared plus 8x minus 3. Y plus 3 equals negative 2x squared minus 4x plus 4 plus 4. Y plus 5. Y minus 8 equals negative 5, because negative 2 times 4 is negative 8, equals negative 2, x minus 2 squared. Y equals negative 2, x minus 2 squared plus 5. Boom. Boom. Your choice. Everybody good? All right. Your job this weekend is 108. Now, some sucker teacher that I stole this from says you got to complete the square. What a clown. Huh? I don't know. I just found it online. No. DeVries loves negative b over 2a. He's like, you guys have met DeVries. Does he look like the kind of guy that wants to do extra work? Does he? Oh.
My brother just finished class, so I just finished class.
All right. I want you to have, once again, as many mathematical tools as possible. I would not expect you to build a house without giving you a power drill. No. So, I have given you this gift, right? Now, remember, although this is easy to do, it does actually require more work, doesn't it? Because it only gives you the Vx, and then you got to sub back in. Right? So maybe if it's a real easy one, you just want to complete the square. But maybe if it's a little barfy, a 2, no B or no C, odd, maybe you want to work with, went too far. Maybe you want to work with that. Who makes the choice? You do. It is 12:13. You are in class for 47 more minutes. Now, it is Friday. We haven't done word games in a while, and I have another math game that I freaking love. You guys may want to play it, you may not. So I'm going to let you work for 15 minutes. Play the word game. I'll show you the other game. Then you have a choice. You can continue to work or you can play the other game. The other game is once again a head-to-head battle with an opponent of yours. But you got 15 minutes to work. Go. All right. So, Madison, it's negative b over 2a, which is 4 over 4, which is 1. So then my Vy is 2 times 1 squared minus 4 times 1 minus 2, which is 2 minus 4 is negative 4 minus 2 is negative 6. So then y equals a is 2, x minus 1 squared minus 6. Then I graph it by going to plus 1 minus 6. I know my y-intercept is negative 2, so that's 0, negative 2. And since I went 1 there, I should have gone up. Since I went 1 there, I should have gone up 1, but it's doubled. Wait a minute. What did I do wrong?
2 squared is 4 minus
4 minus 4 is 0 minus 2. This is minus 2. Thank you. Minus 2. See, Preston? No problem. So that is 1 minus 2. 1 minus 2. And my y-intercept is negative 2. I've still done something wrong. 2 times 2 is 4. Minus 4 is 0. Minus 2 is negative 2. So it's my y is 1. 1, negative 2. My y-intercept. What the hell am I doing wrong? Negative 4. Oh! Negative 4 is positive 4 divided by 2 times that's 2, 1. Yes. 2 times 1 is 2 minus 4. 2 times 1 is 1. 1 squared. So it's 2 minus 4 is it's negative 4. There. Good God. 1 squared is 1. So now, negative 4. Now it's going to graph right. 1, negative 4. 0, negative 2. 1 away, so I got to go 1 away. So that's 2, negative 2, and then I graph.
Okay, I made the same mistake as you. 1 squared.
1 squared is not 2. It's 1. Right? Everybody good? Now, how did I know I was screwing up? Because I knew the y-intercept had to be negative 2, and I was getting a vertex of negative 2. That's impossible. So that's where I'm able to find my mistake. Well, I didn't find my mistake. I found out that I'd made a mistake, and then I started going back and checking. The difference between you guys and me is you just work and you never go back and check. You just follow steps and you don't stop and think if what the answer you've given me makes sense. All of you that were in my grade 10 class, remember 5 steps to walk the length of Vancouver Island.
No. I think 3 steps was mine.
Oh, sorry, 3 steps. Yeah, my mistake. 3 giant steps of 150 kilometers each.
You know what? You take a running start.
All right, so are we good? Should I do one more?
Wait, 2 times 1 is 2. It's not 1.
1 squared is 1. Times 2 is 2. 2 minus 4 is negative 2. Minus 2 more is negative 4. All right, are we good? Want to see the fun game? It's actually cool. Oh, we were going to do the word game first. I don't know if we've done this one. Falling star. A shooting star. It's another word for it. All right. We already did that one. Friend in need. Some kid in the other class started singing. You got a friend in me. Backseat. Jasleen. Tase? All right, so, I just recorded.